notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. Section 1, all of those have been published already. Section 2, all of those have already been published on YouTube in their entirety. Section 3, all of these have already been published on YouTube in their entirety. And that's a total of 51 videos. Please make good use of them. We are now at section 4, measurement. This is the 15th of 17 videos, and I am somewhat behind schedule. January 2025, statistics. February 2025, algebra. March 2025, relations, functions, and graphs. April 2025, geometry and trigonometry. And finally, by May 2025, hopefully, I can still keep this schedule, vectors and matrices. However, there is a disclaimer here. This schedule is just a projection which may or may not be fulfilled. Nobody should interpret this as a contract. As I have already pointed out, the 33 videos from section 1 are all available on YouTube in their entirety. Please make good use of these, since they form the foundation on which the rest of the syllabus is based. A reminder that you need to know the times tables 2 to 12. If you don't know them already, you will have to learn them, especially since calculators are not allowed in paper 1. So as I said, all 12 videos from section 2 have already been published. Section 3, all 6 videos. We are now at section 4. Here, all of those 4 have been published on YouTube in their entirety. These others are only partially published, 2 and 3 and so on, right down to 13. So we are now here at objective 13, margin of error, which is video 15 in this section. This will only be partially published when it is finished. Section 4, objective 13, margin of error. Before we go on, a reminder that you will need a good math textbook or a set of 2 so that you can get more practice questions on these topics. CSEC recommends the following textbooks shown on right here, these. From that list, I would recommend a very good 2-volume set of math textbook, which is quite adequate for a current CSEC math exam. This is a picture of volume 1, Mathematics, a Complete Course with CSEC questions by Raymond Tulsi. And this is a picture of volume 2. Disclaimer, I get no financial or other benefits from the sale of these books. Also, very recently, as of late 2024, a website with AI interactivity has been made available free of cost, and it deals with past CSEC math questions only. You can navigate by topics or years, where all questions for the past several years have been worked out for you. If you have a question that you need explained, you can ask the AI assistant either by text or voice, and most likely that will be explained for you. This is the URL here. And on the next slide, I will show you what the home page looks like for that site. This is the home page here. You would have to register first, and subsequent to that, you would sign in. So from section 4, this is a print screen of that part of the syllabus. All 4 objectives here have been completed, and we continue these 5 more. Now we are on this last page. Those 3 up there, 10, 11, and 12 have been completed. We are now at 13, which says estimate the margin of error for a given measurement. Once we finish 13, basically we only have one more, which is 14. Objective 15, solve problems involving measurement. It's like a review of what we did in this section: perimeter, area, volume, and so on. There are 2 explanatory notes here: sources of error and maximum and minimum measurements. Just a reminder that this is the formula sheet that you will get during the exam, papers 1, 2, and 3. That's the first part. And this is the second part of that same one formula sheet. So you don't have to memorize these formulae. Make sure, though, you know when and how to use them. So as I said, we are here. Estimate margin of error for a given measurement. Firstly, this objective is not about analysis of statistical data. We are not going to deal with something that looks like this over here. Though, to a certain extent, we will be doing a little bit of this down here when we talk about margin of error and maximum and minimum measurements. But we will not deal in detail with statistical analysis of data. So as I said, margin of error. And you can see something here talk about margin of error and margin of error and so on. Now, have you ever bought something that the seller has to measure, often right in front of you? Or a packaged item in a supermarket? Well, I think we all have done that. And also, did you ever wonder at times if you got the correct weight or length or whatever it is measured in? Have you ever wondered if that is correct? If you buy, say, something that is 2 pounds or say something that is 1 kilogram, have you ever wondered if you get the correct weight? Could there be an honest mistake, or worse yet, a deliberate attempt to make you pay for the amount of products you did not get? Of course, if there is more than what we would expect, we don't complain. But when we get less than what we paid for, we are always upset. Let's look at this picture here. It says 1-to-1 organic all-purpose flour, gluten-free. Now, this is termed a health food, gluten-free and organic. It is expensive, and it's used as wheat flour substitute. Fine. But then you look down here and it says 567 grams. 567 grams. Now, do you know that you have 567 grams? Was there actually 567 grams of flour in that package? In this case, a few grams more or less will not make much of a difference. Say 567 plus or minus 7. In other words, 7 grams less, 6 grams less, 4 grams less, and so on. So 4 grams, 5 grams, 7 grams more. So you have a margin of error there, which would be plus or minus 7. Now we read it as plus or minus. It really should be minus 2 plus 7 grams more or less. So are we sure we have 567 maybe a little variation. Most of us will be satisfied with that. How about though, if we have 6 to 7 grams variation and you have to pay the same price? That is 11.8% more. We will be happy for that. But what about if it is less? It would not look like a margin of error. It would look like it was deliberately done to make you pay for the amount of item that you did not get. So let's talk about sources of errors first. Then we will talk about maximum and minimum measurements. Then we will go to estimate margin of error. So really we're looking at 3 different but related items. All measurements have some type of honest error in them. Most can be corrected or minimized if they are recognized for what they are. Errors may arise from mainly 2 categories of mistakes. 2. Systematic and random. What are systematic errors? Systematic errors are caused by a faulty instrument. The instrument itself that you are using to take the measurement has a fault, and it occurs in the same direction every time. In other words, if it's less than what it should be, it will always be less with that instrument. It does not matter who uses the instrument, everybody will get the same error because it's an error caused by the instrument. Example 1. If the instrument is incorrectly calibrated, for example, when it says 2 kilograms, that may actually be 1.9 kilograms, assuming there is no zero error to begin with. So that's an error caused by the instrument. Example 2, if the instrument does have a zero error, for example, when it should read 0, that is, it is not measuring anything at all, it is already reading 1. So straight off you have 2 different errors there caused by the instrument. So those 2 would fall under systematic errors. Example 3, if the instrument is not sensitive enough. For example, if you want to measure the length of a small metal cylinder approximately 3.5 centimeters long, but the sensitivity, the smallest difference the instrument could measure is 1 centimeter. So you would estimate this figure here. Is it 3.4? Is it 3.5? Is it 3.6? Is it 3.3? Now in this case, the person taking the measurement has to make a judgment. We cannot really call that a random error, even though people may make similar errors with this. However, the instrument is not sensitive enough. So we have a fault with the instrument. And then you have compound that with people trying to guess exactly that decimal point. So those are systematic errors caused by the instrument. Then there are random errors, and these are human errors caused by the person reading the instrument. Its direction may not always be the same. In other words, it may not always be greater than the true reading, or it may not always be less than the true reading. Different people will get different readings, although it is not the fault of the instrument this time. For example, error of parallax. This occurs with analog instruments where you're required to take the reading face on, directly in front of the instrument, directly from the front. For example, if you have a meter like this and you are reading it from the side, notice at this point it is actually saying less than 0. But if you were to face it straight on, it would probably say 0, meaning it has no zero error. Now, so what is this reading here? This green line, that green arrow, is that 20, or is it less than 20, if you read it from where it is? Or is it more than 20 if you read it from that same angle that you are looking at? Actually, it will be more than 20. The 20 milliamp? No, if you read it properly, it will be more than 20 milliamp. So we have an error of parallax if you insist in reading it as is. Example 5, use wrong sensitivity. A person may assume that the smallest difference that the instrument can measure is 0.1 or 1 when it may actually be something else, maybe 0.2. So let's look at that same instrument now. Looking at it face on, this time it doesn't have a zero error. What is this reading here? That reading where that green arrow is pointing. Now, some people may say, okay, if that is 20, this will be 21, that will be 22, that will be 23, without evaluating what is the sensitivity on this instrument. Now, to do that, you check from 0 to the first number you could see there, which is 20. Divide that by the number of divisions you have between there, and if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you divide that by 10 and you get 2. So each of those little divisions is 2. So our reading here is not 21, it is actually 22. So that's an error of the person reading the instrument. Is it 21 or 22? Actually 22, because the sensitivity, the smallest difference marked off there, is 2, not 1. Example 6, and this is carelessness or tiredness, results in wrong readings and or recording of the data. For example, you may read 3.86 grams, which may be correct, but then you record it as 3.68 grams. Now, if you find this video useful and interesting, please like and share. That is, like and share. You may also consider subscribing to this channel.